I am Anil Kumar. Welcome to another beautiful video where we are going to introduce multiple concepts. We'll begin with divisibility rule by 7. Most books avoid this, especially at junior levels. And we are going to check that rule with a very beautiful number 6174. It has a specific name. It is called Kapprekar's constant. Kaprekar was a great mathematician from India. You want to learn more about it? Look into a book inspired by math. He has contributed so much and given us so many other numbers, which are a treat to know. They will definitely help to improve your curiosity, reasoning, and critical thinking. Let us explore this number in greater details in this particular video. So, first thing first, we'll talk about divisibility rule by 7. What is it actually? How do we do it? So, few steps to follow. The very first step is to drop the last digit, double it, subtract from the rest. If the result is divisible by 7, so is the number. Repeat this process. Now let's try to understand what it means. So 6174 is our number. The last digit here is 4, right? So first step is drop the last digit. So if I drop this last digit, then we are left with what? We are left with 617. Then it says double it, means last digit has been dropped and it has been doubled, so 4 becomes 8. And later it says subtract from the rest, means after dropping 617 was left, you to subtract 8 from the rest. That's what it means, right? So once again, drop the last digit. 4 in this case has been dropped. We are left with the number 617. Double it. So 4 has been doubled. Subtract from the rest, which is 617. If the result is divisible by 7, so is the number. So if the number is smaller, you may see it very easily. Otherwise, this process will be repeated. So when you take away 8 from 7, you have to definitely borrow. You get 9 here and 0 and 6. We'll repeat this process, right? Since we are not sure whether 609 can be divided by 7 or not. So let's follow this. We'll drop 9, double it, which is 18. Take away 18 from 60. What do you get? So when you take away 18 from 60, we get 10 take away 8 is 2, and 5 take away 1 is 4. We get the number 42. And you know, 42 is divisible by 7. So 42 is divisible by 7. You know, goes 6 times. Since the number reached is divisible by 7, 6174 is also divisible by 7, right? 6174 is also divisible by 7. Do you see how we use this rule and verify that 6174 can be divided by 7, right? So I hope you have understood the rule. Now, we are going to do prime factorization of this number 6174. So prime factorization, we'll take this number 6174. Since we know it can be divided by 7, we could straight away start with 7 also, right? Perfect. And see what do we get. But anyway, we'll keep it simple. First, we know 6174 is an even number. So let's go step by step. We'll divide by 2. Right. Keep it simple. Okay. So when you divide by 2, 2 times 3 is 6, 0, 17 goes 8 times, 14 goes 7 times. Correct. So we got a number which is 3. 8 and 7 adds up to 15, and the sum is divisible by 3, and therefore we can divide this number by 3 also, right? So we divide by 3, and what do we get? 3 times 1, 0, 3 times 2 is 6, and 27, 9. Perfect. You're left with 1029. Now, in this case, 1 plus 2 is 3, 3 plus 9 is 12. You can further divide by 3, right? So, divide by 3. So, it goes 3 times 3, 9, 3 times 4, 12, and 3 times 3 is again 9. So, 343. But see, 343 you cannot divide by 3 since its sum is not divisible by 3. So, you should know the divisibility rules. Perfect. But at this point, we can use 7, right? We just did it, right? So let's divide this by 7 now. We know it goes by 7, and this will be a check, correct? So 7 times 5 is 35, so we'll have to satisfy ourselves by 7 times 4, which is 28. 63, 7 times 9. We're left with 49, which you know is 7 times 7. Perfect. So we get prime factorization of our number 6174, and you can see 7 indeed is a factor of 6174, right? So now we can write this number 6174 as what? As equal to 2, right? Times how many threes are there? We got two threes, right? So 3 times 3, we'll write 3 square here, and we got 3 sevens, right? So this decimal is not a decimal, it is product multiplication sign, and we get 3. 7 cube. Perfect. So now 6174 can be written as 2 times 3 times 3, which is 3 square, times 7 times 7 times 7, which is 7 cube. Right. So we got the prime factorization. And now from here, we have to find another very beautiful thing is how many factors will this number have? Now, how do you find the number of factors from prime factorization? Well, the rule is very simple. Number of factors, let me write number of factors like this. Number of factors, correct. So you see the exponents and add 1 to it. So 2 is only 1. So to find the factors, we may take 1, 2, or we may not take a 2, right? So there are two choices. That's why we get from here 1 plus 1, correct. Now, for 3, there are two threes. So we have got three choices. We may take 1 3, we may take both, or we may not take any 3. So that gives us 2 plus 1, 3 choices. For 7, 7 cube, we got 3 plus 1, which are 4 choices, right? So number of factors is basically equals to 2 times 3 plus 2, which is 5, and 3 plus 1, which is 4. You see, I have written multiplication in many different ways. That dot signifies multiplication, and when you write numbers in brackets, then you don't have to write anything. It indicates multiplication. Makes sense? Right. So 2 times 5 is 10, times 4 is 40, right? So there are 40 factors of the number 6174, correct? See how beautifully, with the help of prime factorization, we could find the number of factors. If I would have started writing those factors, 40 of them, it's very difficult to write all of them. I would have definitely missed some, right? Okay, so we did this. Now, I would like to show you one unique property of 6174, and we are going to explore this number in greater details and celebrate Kaprekar's numbers in our book and in following videos. Correct. So let's look into this prime factorization in greater details, right? So we got 6174 equals to 2 times 3 square times 7 cube, right? So we just did this. Okay. So we are going to use the space 6174 we just found is equal to prime factorization 2 times 3 square. There were two threes and 7 cube. Right. We also figured out there are 40 factors for this number 6174. I'm going to show you a very unique property of this number right here. So see, basically we have got 2 as one of the factors. There are two threes, right? And there are three sevens, correct? 7, 7, and 7, correct? Now, if I add the squares of all the prime numbers, which are factors of 6174, what do I get? This is what we're going to check. And that's what Kaprekar did with his numbers. He went into a lot of details and found so many patterns which amazes the mathematicians even till date. Right. So let's square each one of them. So if I square, I get 2 square times 3 square times another 3, right? And then we have 7 square times 7 square times 7 square, right? So 2 square is 4, right? Let's add these numbers and see what do they give us. Squares of these, right? 3 square is 9, 9 plus 49 plus 49 plus 49. Okay. So add them up, right? So we got 349s, okay? So let me do step by step. So we'll do this first. 9 and 9, 18 plus 4 is 22, right? So 22 plus 349s. So 50 times 3 is 150. So I'll reduce 3, right? So 150 minus 3 will be 147, right? So that gives us 22 plus 147 gives us 169. You see, 169 is 13 square. See the beauty of this number. So, when you get these prime factors of 16174, and if you add squares of each one of them, you get a perfect square, right? Very few numbers have this property. And there are many other properties which we are going to explore for 6174. You watch other videos and see how beautifully Kaprekar, used to entertain students with numbers. And that's what we are going to do in our book, Inspired by Math. That is where the curiosity of the students get built up and the creativity comes up with critical thinking. I hope you are going to enjoy the book as we are enjoying building it up. The book soon will be there in the market. In the month of September, we are going to release it, 2025. Great. Looking forward to your more interest in this book. Thank you and have a great day.